Welcome to Still Science Lab. Tonight, we explore about how can nothingness carry an electromagnetic wave. Light does something that should be impossible. It crosses millions of miles of pure emptiness without any medium at all. Right now, photons from stars that died before Earth existed are sailing through the void between galaxies, through regions where there is not a single atom for trillions of miles. And they arrive here perfectly intact. No air, no water, no substance of any kind, just empty space. Every wave you have ever encountered in your life needs some kind of substance to move through. Take that substance away and the wave dies. So, what exactly is waving? And how can nothing carry something? You have heard waves your entire life. Even if you have never thought about them scientifically, even if you have never opened a physics textbook, you know what a wave is. You have felt the bass from a speaker vibrate through your chest at a concert. You have watched ocean waves roll toward the shore and break into white foam. You have clapped your hands in a quiet room and heard the echo bounce back from the walls. Waves are everywhere. They are one of the most familiar phenomena in the natural world, so common that we barely notice them. But there is something about waves that most people never stop to think about. Something so basic, so obvious that it hides in plain sight. Every wave you have ever experienced in your daily life has one thing in common. Every single one of them needs something to travel through. And when you truly understand why that matters, you begin to see why light is one of the most puzzling things in the universe. Let us start with sound, because it is the wave you encounter most often. Right now, as you listen to these words, sound waves are traveling from your speakers or headphones into your ears. But what exactly is happening? What is a sound wave really? When a speaker produces sound, the driver inside the speaker pushes forward. That push compresses the air directly in front of it, squeezing the air molecules closer together into a region of higher pressure. Those compressed molecules then push on the molecules next to them, which push on the molecules next to them, and so on. The compression travels outward from the speaker like a chain reaction, spreading through the room in every direction. Behind the compression, the air molecules spread apart again, creating a region of lower pressure called a rarefaction. The pattern of compression followed by rarefaction followed by compression again is what we call a sound wave. It is a pressure disturbance rippling through the air. Here is the critical thing to understand. The air molecules themselves do not travel from the speaker to your ear. They do not fly across the room. They just jostle back and forth in place, each one bumping into its neighbor, passing the vibration along. What actually travels across the room is the disturbance, the pattern of squeezing and stretching. The wave moves through the air, but the air itself stays more or less where it was. Think about a line of dominoes standing on a table. When you knock over the first one, it hits the second, which hits the third, and the falling pattern travels down the entire line. But the dominoes themselves do not travel, they just fall in place. Each individual domino only tips over right where it was standing. The wave of falling travels across the table, but the dominoes do not. Sound works in a very similar way. The disturbance propagates. The medium stays put. And this brings us to the most important point about sound. Without air, there is no sound. No air molecules means nothing to compress and stretch, nothing to jostle against its neighbor, nothing to pass the vibration along. The wave simply cannot exist without the material it moves through. The medium is not optional, it is everything. This is not just theory. It has been demonstrated in laboratories since the 1600s. Robert Boyle performed one of the earliest versions of this experiment around 1659. The setup is beautifully simple. You place a small ringing bell inside a glass jar. You can hear it clearly through the glass. The bell vibrates. The air inside the jar carries the sound to the glass walls. The glass vibrates. The air outside the jar carries it to your ears. The chain of transmission is unbroken. Then you start pumping the air out of the jar, creating a vacuum inside. As the air disappears, molecule by molecule, the ringing gets quieter and quieter and quieter, until eventually you cannot hear it at all. The bell is still vibrating. You can see it moving. Its clapper is still striking the sides. But with no air molecules inside the jar to carry the vibration from the bell to the glass, the sound cannot reach you. The wave has lost its medium, and without its medium, it ceases to exist. This is why there is no sound in space. Sound cannot travel through empty space. Every astronaut knows this. In the vacuum between stars, you could scream as loud as you want and nobody would hear you. In science fiction movies, you hear explosions in space. You hear engines roaring. You hear lasers firing with dramatic sounds. None of that would actually happen. Space is a near-perfect vacuum. In the regions between planets, you might find a handful of particles per cubic centimeter, mostly from the solar wind. In deep interstellar space, the density drops even further. In the vast voids between galaxy clusters, there might be fewer than 1 atom per cubic meter. That is not enough material to carry a sound wave of any kind. An astronaut floating outside the International Space Station could bang 2 metal rods together as hard as they wanted, and the only sound they would hear would be what traveled through their spacesuit and the air sealed inside their helmet. Nothing would travel through the vacuum surrounding them. Absolute silence. The emptiness of space cannot carry sound because sound is a vibration of matter, and there is no matter there to vibrate. Sound waves are what physicists call mechanical waves. They are mechanical because they require a physical medium, a material substance to propagate through. Air is the most common medium for sound in our everyday lives, but sound can also travel through liquids and solids. In fact, it travels faster and more efficiently through denser, more rigid materials. Sound moves through air at about 343 meters per second at room temperature. Through water, it moves at about 1,480 meters per second, more than 4 times faster. Through steel, it moves at about 5,960 meters per second, more than 17 times faster than in air. The denser and more rigid the material, the faster the vibration passes from one molecule to the next, because the molecules are packed tighter and respond more quickly to being pushed. This is why whales can communicate across entire ocean basins. A blue whale's low-frequency call can travel thousands of miles through the water because the ocean provides an excellent medium for sound propagation. The water molecules are packed much closer together than air molecules, so the compressions pass along faster and with less energy loss. The ocean is like a superhighway for sound waves. But the same rule always applies. Take away the water and the wave dies. No medium, no wave. That is the rule. Now let us look at another kind of wave you know well. Ocean waves. Ocean waves need water. When you stand on a beach and watch waves rolling in toward the shore, what you are really seeing is energy moving through water. Somewhere out at sea, perhaps hundreds or even thousands of miles away, a storm pushed on the ocean surface. Wind transferred energy to the water. That energy created a disturbance, a pattern of rising and falling on the surface. And that pattern propagated outward from the storm, traveling across vast stretches of open ocean until it reached your beach. But here is something most people do not realize. The water itself is not traveling from the storm to the beach. If you dropped a cork in the middle of the ocean and watched it as a wave passed underneath, the cork would bob up and down in a roughly circular motion, rising as the crest passed, falling as the trough followed, and then ending up almost exactly where it started. The water molecules move in circles. They do not travel horizontally with the wave. What moves across the ocean is the shape, the pattern of rising and falling. The disturbance propagates. The water stays in place. The medium carries the wave by passing the disturbance from one bit of material to the next, each molecule nudging its neighbor, but none of them actually going anywhere. Without the water, the ocean wave cannot exist. This seems almost silly to state out loud. Of course, you cannot have an ocean wave without an ocean. That is like saying you cannot have a ripple without a pond. The wave is a disturbance of the water. Remove the water and there is nothing left to disturb. The wave is not a thing that exists on its own. It is something the medium does. Seismic waves work the same way. When an earthquake occurs deep underground, the sudden release of energy sends vibrations through the Earth's crust and interior. These vibrations travel through solid rock, sometimes for thousands of miles. Primary waves, which arrive first at seismograph stations, compress and stretch the rock in the direction the wave travels, similar to how sound compresses air. Secondary waves move the rock side to side, perpendicular to the direction of travel. Surface waves roll along the ground like ocean waves roll along the water's surface, and these are usually the ones that cause the most damage during an earthquake. But all of them, every type of seismic wave, need the rock and soil of the Earth to travel through. Without the solid ground beneath your feet, seismic waves cannot exist. The medium is essential. Even the wave you do at a sports stadium follows this exact pattern. When fans in one section stand up and raise their arms, the people next to them see this and do the same thing a moment later, and the wave of standing and sitting ripples around the stadium. It looks like something is traveling around the arena and something is a disturbance, a pattern. But the fans themselves stay in their seats. The fans are the medium. Each person passes the disturbance to their neighbor. Without the fans, there is no stadium wave. Without the medium, there is no wave. So here is the rule that emerges from every wave you have ever encountered in your entire life. Waves are disturbances that travel through a physical medium. The medium can be air, water, rock, metal, or even a crowd of people. But there must be something there, some physical substance, some material for the disturbance to propagate through. Remove the substance and the wave cannot exist. It is not weakened. It is not slowed down. It is gone. This seemed like a fundamental truth about the universe. It seemed like one of those rules that had no exceptions. And then there was light. Light does something that no other wave in our everyday experience does. It travels through completely empty space. Right now, light from the sun is crossing about 150 million kilometers of vacuum to reach the Earth. Between the sun and the Earth, there is almost nothing. A sparse scattering of solar, wind particles, some cosmic dust. But for all practical purposes, it is empty. And yet, sunlight crosses that enormous void in about 8 minutes and 20 seconds, arriving with enough energy to warm the planet, drive the climate, and power nearly all life on Earth. Nothing carried it. Nothing supported it. Nothing passed it along from molecule to molecule the way air passes along sound. The light just traveled through emptiness. And this is not limited to the short distance between the sun and the Earth. Light from distant stars travels for years through the vacuum of interstellar space. The nearest star beyond our sun, Proxima Centauri, is about 4.24 light-years away. The light you see from that star tonight has been traveling through empty space for more than 4 years. During that entire journey, those photons encountered almost nothing. They crossed regions where the density of matter is so low, it would make the best vacuum we can create in any laboratory on Earth look positively crowded by comparison. Go even farther. The light from galaxies billions of light-years away has been crossing the void of intergalactic space for billions of years. These photons have traveled through the emptiest regions in the known universe, the enormous voids between galaxy clusters where you might find only a handful of hydrogen atoms in a volume the size of a living room. And still the light arrives. It is fainter because it has spread out over such a staggering distance. Its wavelength has been stretched by the expansion of space. But it arrives. The wave propagated successfully through trillions upon trillions of miles of virtually perfect vacuum with no medium of any kind to support it. This created a tremendous problem for physicists. If every familiar wave in our daily lives requires a physical medium to travel through, we are confronted with a staggering paradox. We are forced to look up at the night sky and reconcile our heavy, terrestrial intuition with a deeply alien cosmic reality. We must confront the undeniable truth that light behaves as a wave, yet it freely navigates a realm entirely devoid of the matter we rely on to carry energy. If a wave is truly just a disturbance of a medium, a fleeting ghost temporarily possessing the material world, then the freezing vacuum of space should logically be an impenetrable wall to the stars. The universe should be dark, fragmented, and utterly disconnected. But it is not. The cosmos is illuminated by a relentless flow of ancient energy bridging the impossible gulfs. And so, we are left staring into the dark, forced to ask a question that shatters our common sense. If all waves need a medium, how does light cross the void? To understand the universe, we often rely on what we can touch, what we can feel, and what we can physically observe in our immediate surroundings. For centuries, the grand architecture of classical physics was built entirely upon this tangible, terrestrial foundation. Every physical action required a physical cause. Every moving object required a physical force to push it. And most importantly, every single wave required a physical medium to travel through. It was a comforting, mechanical worldview that made the cosmos feel like a giant, logical clockwork. But as humanity began to construct better instruments and look closer at the fabric of reality, this mechanical certainty began to fracture. By the early 1800s, the scientific community was embroiled in a fierce intellectual conflict. The debate over the fundamental nature of light had been raging for more than a century, splitting the greatest minds into two opposing camps. At the center of this storm was Isaac Newton, a titan of science whose intellect had mapped the laws of gravity and motion. In his 1704 work on optics, Newton argued with immense, unyielding authority that light was composed of tiny, solid particles, which he called corpuscles. Newton visualized these microscopic particles traveling in perfectly straight lines, bouncing off mirrors and refracting through glass, much like incredibly fast, microscopic billiard balls. Because of Newton's enormous reputation and almost mythical prestige, this particle theory dominated the scientific landscape, carrying tremendous weight for decades. Yet, there was a dissenting voice that refused to be silenced by authority. Decades earlier, in 1678, the brilliant Dutch physicist Christian Huygens had proposed an elegant and radical alternative. Huygens argued that light was not a stream of solid bullets, but rather a wave. He meticulously demonstrated that a wave theory could explain the behavior of light, such as reflection and the bending of refraction, just as well as Newton's particle model could. For a long time, the two theories competed in the minds of natural philosophers, but the sheer gravity of Newton's legacy kept the particle theory dominating the mainstream. The breaking point arrived in 1801, delivered by a brilliant polymath named Thomas Young. Young performed a deceptively simple experiment that would completely shatter the particle illusion and change the course of physics forever. Imagine a dark, silent room. A single, focused beam of light is directed toward an opaque barrier. Cut into this solid barrier are two extremely narrow, parallel slits. If Newton was right, and light was simply a barrage of tiny physical projectiles, those particles should travel in straight lines, pass cleanly through the two openings, and pile up on the screen behind the barrier. They should create exactly two distinct, bright patches of light directly behind the slits. But that is not what Young observed. When the light passed through the two narrow gaps and hit the screen, it did not form two harsh lines. Instead, it painted a sprawling, intricate pattern of alternating bright and dark bands spread widely across the surface. In the strict discipline of physics, this is known as an interference pattern, and it is a phenomenon that only waves can produce. To understand why, you have to visualize the geometry of overlapping ripples. When two waves interact, their energies combine. If the crest of one wave arrives at the exact same point on the screen at the exact same time as the crest of the other wave, they reinforce each other, amplifying their energy to create a bright band of light. But if the crest of one wave arrives at the same time as the deep trough of the other, they are in perfect opposition. They perfectly cancel each other out, leaving behind a band of absolute darkness. Particles cannot behave this way. Two solid objects cannot collide and cancel each other out of physical existence. You cannot take two microscopic bullets, throw them at the same spot, and get nothing. Only waves possess this ghostly, mathematical ability to destructively interfere. The interference pattern on Young's screen was decisive, irrefutable evidence that light is a wave. In the years that followed, the French physicist Augustin-Jean Fresnel developed rigorous, complex mathematics that expanded on Young's ideas. Fresnel showed that the wave theory could also perfectly explain diffraction, the strange phenomenon where light smoothly bends around physical obstacles and creeps through small openings. By the middle of the 1800s, the great debate was finally laid to rest. The wave theory of light was firmly established. Virtually every physicist on Earth accepted the undeniable truth that light is a wave. But this monumental victory immediately birthed a terrifying paradox. The human mind is highly susceptible to logical traps, and the physicists of the 19th century were caught in a massive one. The logic went like this. If light is a wave, then, by every physical principle understood at the time, it must need a medium. Sound is a wave in air. Ocean waves are waves in water. Seismic waves are waves in solid rock. If light is a wave, what is it waving in? What is the physical substance that vibrates, stretches, and compresses as sunlight crosses the freezing, silent emptiness between the sun and the earth? This single question struck at the very heart of the classical worldview. A wave without a medium was considered a logical absurdity. It was a verb without a noun. The thought of a physical disturbance traveling through pure, unadulterated emptiness was so deeply unsettling that the greatest scientific minds of the era simply refused to accept it. Their terrestrial intuition, forged in a world of matter, demanded a material reality. They needed a substance to carry the energy of the stars. And so, out of sheer psychological desperation to save the mechanical universe, they invented a ghost. They proposed that all of space is not a vacuum at all, but is instead completely filled with an invisible, weightless, perfectly transparent substance. They gave this phantom material a beautiful, haunting name, the luminiferous ether. The word luminiferous literally translates to light-bearing. The ether was supposed to be the ultimate cosmic ocean, the unseen medium through which the waves of light propagated, functioning exactly as air acts as the medium for sound. To the 19th century mind, this felt profoundly logical and deeply comforting. Every known wave had a medium, Light was undeniably a wave, and therefore the ether simply had to exist. It was a magnificent fiction designed to preserve order. This substance was imagined to permeate absolutely everything. It filled all of space, occupying the freezing, unfathomable gulfs between distant galaxies, and quietly seeping into every microscopic gap between every atom in existence. But the ether was a fragile illusion. When physicists actually sat down to mathematically interrogate the properties this invisible medium was required to have, the classical logic began to violently tear itself apart. To do its job, the ether had to possess a combination of physical characteristics that bordered on the absurd, existing in a state of impossible contradiction. First, consider the speed at which light travels. The speed of any wave moving through a physical medium is strictly dependent on the stiffness or rigidity of that medium. For example, sound travels significantly faster through a block of solid steel than it does through the open air, precisely because steel is far more rigid. The molecules in steel are tightly bound, allowing them to snap back and pass the vibration to their neighbor with incredible speed. Light, however, travels at a staggering, blistering velocity of approximately 300,000 kilometers per second. For any physical medium to transmit a ripple at that incomprehensible speed, it would need to possess an extraordinary stiffness. It would have to be infinitely more rigid than steel. In fact, for the ether to support a wave moving at 300,000 kilometers per second, it would need to be far stiffer than diamond. It would have to be the most rigid, unyielding material known to exist. But here lies the fatal, inescapable contradiction. Look up at the night sky and consider the celestial bodies drifting in the dark. The planets in our solar system have been orbiting the sun for billions of years without slowing down. If the Earth were constantly plowing through a cosmic ocean of material stiffer than diamond, the friction would be catastrophic. The drag would violently bleed away the orbital energy of every planet, causing them to grind to a halt almost immediately and spiral into the burning heart of the sun. Yet, the planets glide through the dark with absolute, silent grace. The gravitational calculations used by astronomers worked perfectly without having to account for a single ounce of drag from the ether. Therefore, the ether had to be essentially massless. It had to offer absolutely zero resistance to objects moving through it. How can a single substance be simultaneously stiffer than diamond to carry light at maximum velocity, yet offer absolutely no physical resistance to a massive planet carving a path through it? These requirements were deeply, fundamentally contradictory. It was starting to sound less like a real physical substance governed by natural laws and more like a convenient fiction. It was a mere name given to a desperate hope, a label for something nobody could actually find. But despite this glaring, fatal logical flaw, the physicists of the era pressed on with their search. They saw absolutely no alternative. Their logic seemed utterly airtight. Light is a wave. Waves absolutely need media. Therefore, the ether must be real. They had fallen into a profound cognitive trap, blinded by their own terrestrial intuition. By projecting the mechanical rules of our heavy, material world onto the infinite canvas of the cosmos, they had hidden a much more beautiful and terrifying truth from themselves. The universe is not obligated to make sense to a primate mind evolved to throw rocks and swim in water. The invention of the luminiferous ether was the ultimate hubris of classical physics. It was the desperate attempt of a dying worldview to hold on to the illusion of a solid, tangible reality, right before the universe pulled the ground out from beneath our feet entirely, leaving us to fall into the true nature of the void. There is a quiet, terrifying realization that comes when you ask the universe a perfectly logical question, and the universe responds with absolute silence. For the scientific community of the late 19th century, the universe was supposed to be a solved puzzle. The mechanical laws of reality were beautifully mapped, the grand clockwork was understood, and the invisible, light-bearing fluid known as the luminiferous ether was the final, necessary piece required to make the entire cosmos make sense. The ether was the comforting ocean upon which the waves of starlight sailed. It was the unquestioned foundation of physical reality. All that remained was to build a machine sensitive enough to actually touch it. To feel this invisible ocean, one only had to look at the staggering velocity of our own planet. The Earth is not stationary. We are hurled through the freezing dark, orbiting the sun at a blistering speed of about 30 kilometers per second. If the ether truly fills all of space, and the Earth moves through it as it orbits the sun, then the Earth must be plowing through this unseen substance like a massive ship carving its way through perfectly calm water. Because of this violent, continuous motion, there should be a measurable resistance. There should be an ether wind blowing past the Earth at that exact speed of 30 kilometers per second. Just as you feel a rush of wind against your face when you drive down a highway with the car window rolled down, even if the air outside is perfectly still. The ether wind was the key. If humanity could detect this subtle cosmic breeze, the ghost medium would be proven real, and the mechanical universe would be saved. In 1887, two American physicists, Albert Michelson and Edward Morley, stepped forward to catch this invisible wind. Together, they designed what would eventually become one of the most famous and ultimately most devastating experiments in the entire history of science. They knew that to measure something as intangible as the ether, they could not use physical scales or mechanical gauges. They had to use the one thing that intimately interacted with the medium. They had to use light itself. Michelson had invented an instrument of breathtaking ingenuity and sensitivity, a device perfectly suited to detect the microscopic variations they were looking for. That instrument was an interferometer. The underlying logic of the device relied on a brilliant, intuitive metaphor. Imagine a swimmer diving into a moving river. If the swimmer swims directly upstream against the current, they will struggle, and their progress will be slower. If they turn around and swim downstream with the current pushing them along, they will move faster. Light, traveling through the ether wind, should behave in the exact same mechanical way. Light traveling in the same direction as the Earth's motion through the ether should appear slightly slower, fighting the current like a swimmer going upstream. Conversely, light traveling in the opposite direction should appear slightly faster, like a swimmer going downstream. And light traveling perfectly perpendicular to the ether wind should have an entirely different, calculable speed. The interferometer was a masterpiece of optical engineering designed to force light into this cosmic race. The device took a single, concentrated beam of light and split it into two perpendicular paths of perfectly equal length. It sent each severed beam out into the dark to strike a precisely angled mirror and bounce back, before ultimately recombining the two beams into one. If the ether wind truly existed, washing over the laboratory as the Earth hurtled through space, it would affect the two beams differently. If one path was aligned perfectly with the ether wind and the other path was perpendicular to it, the two beams would experience different levels of resistance. They would travel at slightly different speeds, and as a result, they would return to the center slightly out of sync. Because light is a wave, this tiny timing difference would create a profound physical signature. When the out-of-sync waves recombined, they would destructively and constructively interfere with one another. This timing difference would create a shifting in the interference pattern, producing a measurable, visible change in the alternating bands of light and dark. Michelson and Morley simply had to watch these bands. If the shadow stripes shifted, it meant the speed of light was changing. It meant the ether wind was real. but measuring a subtle shift in the speed of light required absolute, uncompromising isolation. The interferometer was so impossibly sensitive that the mere footfall of a passing pedestrian, or the distant rumble of a horse-drawn carriage on a cobblestone street, could vibrate the mirrors and completely ruin the data. To insulate their delicate trap from the noisy, vibrating world of the late 19th century, Michelson-Morley built an isolation chamber of magnificent proportions. They mounted the entire apparatus on a massive, heavy stone slab. But stone resting on the ground can still absorb the tremors of the earth. So, they took this massive stone slab and floated it in a circular pool of liquid mercury. This silvery, liquid foundation isolated the instrument from nearly all terrestrial vibrations. Furthermore, floating the heavy stone in mercury allowed the physicists to rotate the entire massive apparatus smoothly, seamlessly, and without the slightest friction, enabling them to test the beams of light against different orientations of the ether wind. In the dim, quiet isolation of their laboratory, with the heavy stone slowly turning on its bed of liquid metal, Michelson-Morley set their trap. They aligned the mirrors. They unleashed the light. They leaned in, holding their breath, and stared at the projected bands of shadow and illumination, waiting for the interference pattern to shift. Nothing happened. The bands of light and dark remained perfectly, stubbornly frozen. Thinking it might be a temporary alignment issue, or a fluke of the Earth's immediate trajectory, they ran the experiment over and over. They meticulously rotated the massive stone slab, searching for the current. They tried conducting the test at different times of day, when the Earth's rotation pointed the laboratory in entirely different directions. They patiently waited for the planet to travel along its vast orbital path, repeating the experiment in different seasons when the Earth was moving through the purported ether from radically different angles. The result was always the exact same. Nothing. No shift, no difference, no ether wind, zero. The speed of light was identical in every conceivable direction, completely regardless of how the Earth was moving through space. The interference bands refused to move. The universe refused to yield the wind. This result did not just confuse the physics community, it absolutely stunned them. It struck a devastating blow to the very foundation of classical mechanics. Michelson-Morley had built the most sensitive instrument they possibly could, an optical trap designed specifically to detect the one mechanical effect the ether was mathematically required to produce if it actually existed. And they found absolutely nothing. It remains one of the most important, catastrophic null results in the entire history of science. They went looking for the very fabric of the cosmos, with every powerful tool available to human ingenuity, and the fabric simply refused to appear. The philosophical implications of this failure were terrifying. If there was no measurable ether wind, there were only two logical conclusions. The first conclusion was that the Earth was not moving at all, that our planet was sitting perfectly stationary in the center of the universe. This, of course, was an astronomical absurdity that would require discarding centuries of proven orbital mechanics. The only remaining conclusion was that the ether, the invisible ocean that carried the light of the stars, the absolute cornerstone of 19th century physics, simply did not exist. Faced with this existential dread, a profound panic swept through the theoretical establishment. The greatest minds of the era could not bear to let the mechanical universe die. They could not accept a reality where waves traveled through pure nothingness. And so, some physicists desperately tried to save the ghost. The Irish physicist George Fitzgerald and the Dutch physicist Hendrik Lorentz independently proposed a mathematical rescue that bordered on the surreal. They looked at the frozen bands of light on Michelson's interferometer, and they hypothesized that the universe was actively hiding the ether from us. They proposed that as the Earth moves through the invisible fluid, the physical matter of the planet and the metal and stone of the interferometer itself physically contract in the direction of motion by exactly the precise amount needed to perfectly cancel out the effect Michelson and Morley were desperately looking for. It was an act of sheer intellectual desperation. They argued that the ether wind was real, but the heavy stone slab was literally shrinking as it pushed through the current, shortening the path of the light just enough to make the speed appear perfectly constant. This was a clever, brilliant mathematical rescue, but to anyone looking closely, it felt exactly like a patch. It was an arbitrary assumption added specifically to explain away why an experiment had failed. The rescue attempts grew increasingly elaborate, requiring more and more convoluted rules to explain why the ether must absolutely exist but could never, under any circumstances, be detected. For nearly 2 decades, physics lived in this agonizing state of denial, wrapping the dying mechanical universe in thicker and thicker layers of mathematical bandages. Then, in 1905, a young patent clerk sitting in an office in Bern, Switzerland, looked at the tortured, bleeding framework of classical physics and decided to cut the knot entirely. Albert Einstein took a radically different approach to the agonizing problem of the vacuum. Rather than constructing elaborate, invisible excuses to explain why the ether could not be found, he simply discarded it entirely. He looked at the null result of the Michelson-Morley experiment not as a failure, but as a profound revelation about the fundamental architecture of reality. Einstein proposed his special theory of relativity, a framework that completely destroyed the Newtonian illusion of absolute space and absolute time. He started from 2 deceptively simple, devastating principles. First, that the laws of physics are the exact same in all inertial reference frames. And second, that the speed of light in a vacuum is exactly the same for all observers, completely regardless of their own motion or the motion of the light's source. Einstein did not bother trying to patch the ether. He proved that there was no mention of the ether needed at all. There was no invisible fluid filling space, and no cosmic medium serving as the absolute background of the universe. Light simply travels at a fixed, absolute speed through empty space, and that unyielding speed never changes, no matter how fast you are moving or in what direction you hurl yourself through the dark. It was a stroke of absolute genius that revolutionized human understanding and gave birth to the modern era of physics. But in solving the mathematical crisis of the era, Einstein's blade had severed the safety rope. By officially discarding the ether, he left the original, horrifying problem wide open. And now, without the comfort of a phantom fluid, it was even more urgent and terrifying than before. The universe was stripped bare. We were forced to accept the undeniable, experimental truth. We know, without a shadow of a doubt, that light is a wave. Thomas Young's glowing interference patterns proved it produces interference, and decades of rigorous observation had confirmed it. We know it travels through the freezing, vast expanse of empty space. Every observation of warm sunlight and ancient starlight confirms this, and thanks to a floating stone slab in a silent basement, we know with absolute certainty that there is no invisible substance filling space for it to wave through. The ghost medium was dead. The vacuum was real. The universe was completely empty. And so, humanity was left standing on the edge of the abyss, staring out into a cosmos filled with brilliant, soaring light, haunted by the ultimate, unresolved paradox. If there is no ether, if the space between the stars is a true and absolute void, what is happening? What is waving? How can a wave exist in pure, unadulterated emptiness. Imagine a solitary proton floating in the absolute darkness of a perfect vacuum. It is entirely alone in otherwise empty space, isolated from the bustling world of matter, suspended far away from the interior of any atom. Is the space surrounding this tiny particle truly empty? If you were to somehow look at the space around that proton with impossibly powerful eyes, you would see nothing at all. There is no material substance surrounding it. But imagine bringing a second charged particle, like an electron, into that same dark expanse. The electron does not need to touch the proton, and it does not even need to be anywhere near it. Yet, the exact moment you place that electron in the surrounding space, it instantly feels a force. It is irresistibly pulled toward the proton. An unseen, attractive tether acts on it immediately, tugging it aggressively in the direction of the positive charge. The electron accelerates, its trajectory irrevocably altered because something is pulling on it. And that something is acting across completely empty space, reaching across a gap that contains absolutely nothing at all. What exactly is doing the pulling? For centuries, the brightest minds in science struggled with this profound and haunting mystery. In the 1600s and 1700s, the standard answer provided by the physics community was a concept called action at a distance. The accepted explanation was that the proton essentially reached across the empty space and instantly tugged on the electron, requiring no mechanism and offering no physical explanation for how the force was actually transmitted through the void. The brilliant physicist Charles-Augustin de Coulomb formalized this mathematical relationship in 1785 with his famous inverse square law. He proved that the force between two charged particles is proportional to the product of their charges, and inversely proportional to the square of the distance separating them. Double the distance, and the force drops to 1/4. Triple the distance, and it drops to 1/9. The mathematics were clean, precise, and perfectly matched experimental reality. But they left a deeply uncomfortable question completely unanswered. How does the proton know the electron is out there in the dark? How does a physical force traverse a completely empty gap when there is no rope, no string, and no mechanism between them? The idea that a particle simply reaches across space and pushes or pulls instantaneously bothered a lot of physicists. But because the math worked so flawlessly, most of them set their discomfort aside and moved on. Then came a man who refused to move on, a man who possessed a completely different kind of genius. Michael Faraday would completely shatter this classical illusion and change the trajectory of physics forever. Faraday's story is one of the most extraordinary in the history of science. He was born in 1791 in South London into a poor family, and he received almost no formal education. At the age of 14, he was apprenticed to a local bookbinder. But Faraday did not just bind the books, he devoured them. He read the science texts that passed through his shop and grew entirely obsessed with electricity and chemistry. He began attending public lectures by the famous chemist Humphrey Davy at the Royal Institution, taking meticulous, passionate notes. Through sheer determination, he talked his way into a position as Davy's laboratory assistant, ultimately rising from a humble apprentice to become one of the greatest experimentalists the world has ever known. However, Faraday harbored what was considered a fatal flaw in the elite academic circles of the 19th century. He could not perform advanced mathematics. This was widely viewed as a serious limitation, causing many of his more mathematically inclined peers to look down on his ideas. They wrote the language of the universe in complex equations, while he spoke in concepts. Yet, this apparent limitation turned out to be his most unprecedented advantage. Because Faraday lacked the mathematical training to rely on abstract symbols, he was forced to think entirely in pictures, relying on physical intuitions and highly detailed mental models. He needed to mentally visualize what was actually happening in the dark, empty spaces surrounding charged objects and magnets. This unique perspective led him to an insight that fundamentally rewrote the rules of reality. Faraday utterly rejected the deeply unsettling idea of action at a distance. He proposed a radical, breathtakingly elegant alternative. He argued that a charged particle does not simply reach its ghostly hand across the void to pull on other charges. Instead, a charged particle actively creates something in the space immediately around it, fundamentally modifying the space itself. The space surrounding a charge is physically different from the space far away from any charge. Faraday called this invisible modification a field. According to Faraday, every charged particle is surrounded by an electric field that extends outward in all directions, completely filling the space around it. This field gets progressively weaker with distance, but it never entirely disappears. The electric field is there whether or not a second charge is present to feel its effects. It is not a temporary response to another particle. It is a permanent property of the space surrounding the initial charge. Faraday visualized these fields vividly in his mind, sketching them in his notebooks as beautiful, flowing curves. He drew lines of force radiating outward from positive charges and converging inward toward negative charges, filling the space around charged objects. He imagined these lines as being dense and tightly packed close to the charge where the field is strong, and spreading farther apart at greater distances where the field grows weak. For Faraday, these sweeping curves were not just convenient mathematical tools drawn on a page for the sake of calculation. He deeply believed that the lines were real, physical entities. He believed the field was a genuine, physical thing filling the empty space around charged objects. This represented a seismic philosophical shift in human understanding. Before Faraday, the space between two interacting charges was considered truly empty, nothing more than a barren gap across which magical forces somehow operated. After Faraday, the space between those charges was filled with something incredibly profound: the field. We must pause to fully grasp the strange, elusive nature of this entity. The field is not matter. It is not composed of atoms or molecules, and it does not possess mass in the traditional sense that we associate with physical objects. You cannot bottle a field, and you cannot place it on a scale to weigh it. And yet, it is undeniably, absolutely there. It physically occupies space. It holds a specific strength and a specific direction at every single microscopic point. And most importantly, it is the field itself that acts as the physical transmitter of the force. In Faraday's brilliant picture of the cosmos, the lonely proton does not reach across the empty space to grab the electron. Instead, the proton generates an electric field in the space all around it, which exists everywhere, radiating outward and saturating the vacuum. When the electron wanders into this field, the electron interacts solely with the field at its own exact location. The field pushes directly on the electron, right where the electron is currently sitting. The force is entirely local. The electron is only responding to the invisible conditions of its immediate vicinity, not to the distant proton. The two particles never actually directly interact with each other. They each interact with the omnipresent field, and the field serves to mediate the force between them. This profound realization extends far beyond electrical charges. Let us look at magnetic fields, for they form the other vital half of this cosmic architecture, working in a remarkably similar way. If you have ever played with magnets, you know they possess an invisible strength that can attract certain metals. You know they can attract or repel one another, and if you hold two strong magnets close together, you can viscerally feel that invisible push or pull hovering between your hands. What you are feeling is a magnetic field actively at work. A magnet creates a magnetic field in the space immediately surrounding it, extending outward in all directions and filling the space. The field is highly concentrated and strongest near the poles, and becomes weaker farther away. And here is the critical revelation that dismantles the classical void. The magnetic field exists in the empty space around the magnet, not just inside the solid metal of the magnet itself. It exists inside the magnet too, but its reality boldly extends outward into the surrounding vacuum. If you were to take a magnet, place it in a sealed chamber, and systematically pump out every last molecule of air to create a flawless vacuum, the magnetic field would still be there, untouched and perfectly intact. You could prove this by bringing another magnet or a piece of iron nearby and watching it respond to the invisible pull. The magnetic field seamlessly fills the vacuum just as readily as it fills an atmosphere of air or an ocean of water. It absolutely does not require a physical substance to support its existence. Faraday famously demonstrated the undeniable reality of this invisible architecture with his beautiful iron filings experiments. He would place a solid magnet underneath a crisp sheet of paper and gently sprinkle tiny iron filings across the top. Instantly, the filings would snap into alignment along the unseen magnetic field lines, suddenly revealing a gorgeous, curving geometric pattern. The elegant curves sweep majestically from one magnetic pole to the other, arching through space, creating a pattern that is both aesthetically breathtaking and deeply informative. But it is crucial to understand that the iron filings do not create the field. They simply serve to make the field visible to human eyes. The sprawling, sweeping field was already there before the iron was ever sprinkled, and it would persist in perfect silence if no filings existed in the universe at all. The filings are merely a crude, physical tool used to observe something fundamentally intangible. This is the great, shattering insight that begins to solve the paradox of the wave. Electric and magnetic fields are real, physical things that exist in completely empty space. They are not material substances, and they are not constructed from atoms, but they are absolutely real. They boldly fill the vacuum, they carry physical energy, and they exert genuine, measurable forces on charged particles and magnetic objects. A region of pure, empty space that contains a strong electric field is physically, fundamentally different from a region of empty space that does not. The field is something, and it is something that stubbornly refuses to require matter to exist. But Faraday's legacy was just the dawn of the revolution. The truly world-altering discoveries involved unlocking the hidden relationship between these two invisible forces, which were deeply and fundamentally connected. For a very long time, electricity and magnetism were viewed as entirely separate mysteries. Electric charges produced electric forces, and magnets produced magnetic forces, acting as two different things that merely happened to coexist in the universe. The first hint of a deeper truth came in 1820, when the Danish physicist Hans Christian Ørsted noticed something unexpected during a lecture demonstration. While demonstrating an electric current flowing through a wire, a compass needle sitting nearby suddenly deflected, swinging away from magnetic north to point directly toward the charged wire. When the direction of the electric current was reversed, the compass needle immediately swung the opposite way. Ørsted realized that the flowing electric current was actively generating a magnetic field. Electricity creates magnetism. The French physicist André-Marie Ampère expanded upon this, showing that the magnetic field wraps around a current-carrying wire in concentric, curling loops. Knowing that a steady flow of electricity creates a steady magnetic field, Faraday became obsessed with finding the reverse effect. He wondered if a steady magnetic field could create a steady electric current. He spent years relentlessly searching, testing every conceivable arrangement of steady magnets and coils of wire, but found nothing. A steady magnetic field, regardless of how immensely powerful it was, produced absolutely no current in a nearby wire. Then, in 1831, Faraday achieved the breakthrough that would forever alter the course of human civilization. He discovered that while a steady field does nothing, a changing magnetic field actively produces an electric current. When he forcefully pushed a magnet through a coil of wire, a current surged through the wire for as long as the magnet was moving. When he stopped the motion, the current instantly died. When he pulled the magnet back out, the current flowed again, but in the exact opposite direction. It was not the static presence of the magnetic field that birthed the electricity. It was the change. A magnetic field that is actively getting stronger, getting weaker, or changing its direction inherently induces an electric field that can drive charges through a wire. This profound phenomenon is known as electromagnetic induction, and it is the beating heart of virtually every electrical power plant on Earth today. Yet, the practical applications of this discovery, as monumental as they are, pale in comparison to the deep, physical principle it revealed. A changing magnetic field creates an electric field. But this creation is not confined to wires, and it is not limited to the interiors of metal conductors. A changing magnetic field actively creates an electric field in pure, empty space. The physical wire is merely a tool that allows us to detect it, but the wire is not fundamentally necessary for the field to be born. If a magnetic field is shifting, rippling, or oscillating in some dark, isolated region of the vacuum, an electric field spontaneously appears right there alongside it. The field brings another field into existence. It requires no underlying matter, no vibrating atoms, no hidden ether, and absolutely no conducting electrons. It requires only empty space and a state of change, leaving the universe forever transformed by the invisible architecture of the void. There is a profound beauty in the search for symmetry, a deep and unyielding belief among theoretical physicists that nature rarely leaves a canvas half-painted. When scientists attempt to map the unseen architecture of the cosmos, they instinctively look for balance. By the middle of the 19th century, the scientific community had uncovered the existence of invisible electric and magnetic fields, but their understanding of these phenomena was fragmented, like scattered pieces of an incomplete puzzle. In the 1850s and 1860s, a Scottish physicist named James Clerk Maxwell took on the monumental task of assembling everything known about electricity and magnetism into a single, unified mathematical framework. Maxwell was a theoretical physicist of staggering ability, possessing a mind that is often ranked alongside Isaac Newton and Albert Einstein as one of the greatest in the history of science. He looked at the brilliant experimental discoveries of his predecessors, including Michael Faraday, Hans Christian Ørsted, and André-Marie Ampère, and he translated their physical intuitions into a set of precise mathematical equations. But in the painstaking process of building this unified framework, Maxwell noticed a glaring imperfection. The equations, exactly as they stood at the time, were fundamentally incomplete. There was a mathematical inconsistency embedded within them, a frustrating situation where the accepted laws of electricity and magnetism actively contradicted each other. Faraday had already proven in the laboratory that a changing magnetic field creates an electric field. However, the existing mathematics possessed no corresponding term for changing electricity creating magnetism. There was a profound and deeply unsettling asymmetry. A changing magnetic field could give birth to electricity, but the equations remained entirely silent on whether a changing electric field could birth a magnetic one. Maxwell realized that to make the equations mathematically consistent, he had to take a leap of absolute faith and add a new term. He boldly proposed that a changing electric field also creates a magnetic field. This was not a conclusion drawn from direct observation. No scientist had ever observed this specific effect occurring in a laboratory. It was a purely theoretical prediction, a mathematical correction Maxwell added simply because the equations demanded it. He called this bold, invisible addition the displacement current, and he inserted it into the equations governing magnetic fields. This single, theoretical addition was one of the most profound and far-reaching insights in the entire history of physics. Suddenly, the mathematical relationship between electric and magnetic fields was perfectly, beautifully symmetrical. A changing magnetic field creates an electric field, and a changing electric field creates a magnetic field. Each one is completely capable of bringing the other into existence. They are inextricably locked together in a reciprocal relationship. Think about what this extraordinary symmetry actually means when applied to the freezing, dark vacuum of deep space. Imagine you have a changing electric field occurring in some completely empty region of the cosmos. That changing electric field immediately creates a magnetic field in the space nearby. But because that magnetic field just came into existence, it is, by definition, changing. And because a changing magnetic field must create an electric field, it spawns a new electric field, which is also changing, which then creates yet another changing magnetic field. Each field generates the other, which generates the first, which generates the other, continuing onward in an endless, self-sustaining chain. Crucially, this cycle does not stay trapped in one single location. Each newly created field appears a little farther out from where the last one was. The electric field creates a magnetic field slightly ahead of itself. That magnetic field creates an electric field slightly farther ahead, and the disturbance leaps outward. It propagates not through a material substance, but entirely through the fields themselves. Each field regenerates the other, leapfrogging forward through the vacuum in an infinite dance of mutual creation. Let us build this majestic engine from scratch to see its physical reality clearly. Imagine a single charged particle, an electron, sitting absolutely alone in otherwise empty space. It is surrounded by a static electric field, extending outward in every direction. Because it is static and unchanging, no magnetic field is created. The fields are quiet, and nothing is happening. Now, imagine you grab that electron and accelerate it sharply, violently jerking it upward in one direction. The electric field surrounding the electron is instantly forced to adjust to this new reality. But the field cannot update everywhere in the universe simultaneously, because changes in the field do not happen instantaneously. They propagate outward at a finite speed. Close to the accelerated electron, the field updates quickly to reflect the new position. But far away in the deep vacuum, the field still looks exactly as though the electron is in its old position, because the information about the sudden movement simply has not arrived there yet. This delay creates a kink in the field, a sharp, localized disturbance where the field is rapidly changing from its old configuration to its new one. This kink propagates outward, expanding rapidly like a ripple spreading from a heavy stone dropped into a calm pond. That outward moving kink is a region of rapidly changing electric field. And, because of Maxwell's brilliant realization, we know that a changing electric field creates a magnetic field. So, a new magnetic field appears, embedded directly within that propagating kink. That new magnetic field is also changing, which creates a new electric field, continuing the chain indefinitely. Once the kink leaves the immediate vicinity of the charged particle, it is entirely on its own. The electric field no longer needs the original electron to sustain it. The wave is entirely self-sufficient. It races outward as an autonomous disturbance in the fields of empty space, needing no push from behind, no pull from ahead, and no material medium to carry it. The electron gave the wave its initial birth, but from that microsecond forward, the wave does not look back. It does not need the source to keep feeding it energy. This self-sustaining nature means that electromagnetic waves can travel indefinitely through empty space. There is no friction in the vacuum to slow them down. There is no material medium to absorb their energy, or molecules to jostle and lose energy to heat. In a perfect vacuum, an electromagnetic wave will travel forever, maintaining its frequency and its speed, crossing any staggering distance the universe allows. But how fast does this leapfrogging engine actually move? The speed at which this self-regenerating disturbance travels is dictated by the fundamental properties of empty space itself. Maxwell was able to mathematically calculate this speed. He derived it entirely from known constants that had already been meticulously measured in laboratory experiments involving capacitors and inductors. These early, earthly experiments had absolutely nothing to do with light. The physicists measuring these constants were simply trying to understand how capacitors store electric charge and how electromagnets function. Nobody measuring these values was thinking about stars, sunshine, or the cosmic nature of light. These two laboratory constants describe exactly how empty space responds to electric and magnetic fields. The electric permittivity of free space describes how strongly the vacuum resists the formation of an electric field. A higher permittivity means the vacuum is harder to polarize electrically. The magnetic permeability of free space describes how readily the vacuum supports a magnetic field. These are not properties of any physical material. They are properties of pure emptiness. They describe the fundamental electromagnetic character of the vacuum. When Maxwell took these two intrinsic properties of empty space and combined them in his newly perfected equations, the result was a thunderbolt. The mathematics revealed that electromagnetic disturbances should propagate through empty space at approximately 300,000 kilometers per second. This was exactly the known speed of light. The correspondence was far too precise to be a mere mathematical coincidence. Think about the sheer, staggering magnitude of what had just occurred. A man sitting quietly at a desk with a pen and paper, logically working through equations about magnets and electric charges, had just derived the speed of light. He had not used a single optical instrument. He had not used prisms, mirrors, or lenses, and he had not performed any experiments measuring the stars. He merely took the known laws of electricity and magnetism, filled in a mathematical gap for the sake of perfect symmetry, and the speed of light fell out of the equations entirely unbidden. Two entirely separate branches of human inquiry, optics and electromagnetism, which had been studied completely independently for centuries by different scientists asking completely different questions, turned out to be the exact same thing. Maxwell concluded, with characteristically brilliant understatement, that light and magnetism are affections of the same substance, and that light is simply an electromagnetic disturbance propagating through the field according to electromagnetic laws. Light is an electromagnetic wave. This breathtaking revelation fundamentally shatters our classical, mechanical understanding of the void. An electromagnetic wave absolutely does not need an external, physical medium to carry it across the universe. The oscillating electric and magnetic fields are not something the wave travels through. They are the wave itself. Unlike a sound wave, which is merely a temporary disturbance of pre-existing air molecules, an electromagnetic wave brings its own oscillation into existence. In the moments before a wave arrives at a given point in empty space, the fields are quiet. The fields do not sit in the dark waiting to be vibrated like air molecules waiting for a sound. The wave actively creates the oscillation, carrying it forward through the relentless, self-generating process of changing fields producing more changing fields. The vacuum of space inherently supports these fields. That capability is built directly into the fabric of reality. Empty space is not a featureless, empty container. It possesses real, measurable properties, a specific electric permittivity and magnetic permeability, which completely dictate the absolute speed limit of the cosmos. The speed of light is not an arbitrary cosmic speed limit chosen at random by the universe. It is a fundamental property encoded in the very way empty space itself responds to electric and magnetic fields. If the vacuum had a slightly different permittivity or a different permeability, light would travel at a completely different speed. The universe contains a kind of physical reality that is fundamentally different from matter. Fields are not made of particles, they do not have mass like a rock or a planet, yet they are absolutely real. They are the invisible infrastructure of reality, the hidden framework that makes forces possible, connecting charged particles across empty space and carrying energy from stars to planets across trillions of miles of vacuum. The electromagnetic wave needs no medium because it is its own medium. It creates the conditions for its own propagation as it travels, actively laying down the road it travels on, one oscillation at a time, advancing at the speed of light through regions that contained absolutely nothing before the wave arrived. The emptiness between the galaxies is not a dead, barren wasteland. It is an exquisitely tuned arena, possessing the exact properties required to carry the self-sustaining engine of light across eternity. There is a profound and humbling realization that comes when we finally accept the limitations of our own biology. For the vast majority of human history, we believed that the light we could see with our eyes was all the light that existed. We looked up at the sky and saw the blazing gold of the sun, the pale silver of the moon, and the rich, vibrant tapestry of colors painting the clouds at dusk. We trusted our senses completely. We assumed that the visual world, this narrow sliver of illumination, was the full extent of reality. But human vision is merely a biological keyhole. Our eyes are highly specialized instruments forged by evolution to detect only the specific frequencies of light that happen to penetrate our planet's thick atmosphere most easily. We are, in truth, almost entirely blind to the actual universe. When James Clerk Maxwell finally unlocked the profound mathematics of the electric and magnetic fields, he did not just explain the nature of visible light, he accidentally exposed a staggering, invisible cosmos. As he wrote out his equations, detailing the exact mechanism by which a changing electric field creates a changing magnetic field, he noticed something incredibly revealing. The equations did not specify a frequency. They did not dictate that these oscillating fields had to vibrate at the specific rates that our human eyes are built to detect. The mathematics held no inherent upper limit and no lower boundary. They simply stated that any electromagnetic disturbance, oscillating at absolutely any frequency, would sustain itself and propagate through the vacuum of space at the exact speed of light. This meant that there had to be an entire spectrum of electromagnetic waves, an infinite landscape of invisible light filling the empty void, carrying energy across the dark, operating completely beyond the limits of human perception. To grasp the sheer scale of this hidden reality, imagine the entire electromagnetic spectrum as a grand piano keyboard, with its keys stretching all the way from one side of a continent to the other. The tiny band of visible light, all the red, orange, yellow, green, blue, and violet that makes up our entire visual experience, would be the width of a single, solitary key located somewhere near the middle. Absolutely everything else on that massive, continent-spanning keyboard is completely invisible to us. If we move down this keyboard, exploring frequencies lower than the deepest red our eyes can perceive, we enter the realm of infrared radiation. Every object in the universe that holds any thermal heat above absolute zero emits infrared light. You cannot see it, but your skin can feel it. When you hold your hands near a campfire on a freezing night and feel the intense warmth radiating against your palms, you are not touching the flames. The warmth is carried across the physical gap of empty air by electromagnetic waves oscillating at frequencies just below human vision. Move further down the spectrum to even lower frequencies, and you encounter microwaves. These are the exact same waves that agitate the water molecules inside your food, converting electromagnetic energy directly into thermal heat. And if you go further still, you reach the lowest frequencies of all, the sprawling domain of radio waves. Radio waves can be hundreds, thousands, or even millions of miles long from crest to crest. Every radio broadcast, every television signal, every Wi-Fi connection in your home, every cell phone call, and every ping from a satellite orbiting in the freezing dark. All of humanity's digital chatter is carried by these vast, invisible waves. When you make a call on your mobile device, the signal does not travel through the air like a sound wave. The air molecules have absolutely nothing to do with it. The signal travels entirely through the electromagnetic field structure of the space between your phone and the nearest tower. If you could somehow magically remove every single atom of air from the atmosphere, creating a perfect, unyielding vacuum, the radio waves would still flow perfectly. They are field disturbances propagating through the intrinsic properties of space itself. Now, imagine traveling in the opposite direction, moving up the cosmic keyboard to frequencies far higher than the most piercing violet light our eyes can process. Here, the wavelengths become microscopic, and the energy grows increasingly violent. We enter the domain of ultraviolet radiation. These waves oscillate with such intense energy that they can physically shatter the delicate chemical bonds of your DNA, which is why exposure to the raw ultraviolet light of our sun can be so incredibly dangerous to biological life. Move higher still, and you reach X-rays. These waves are so small and vibrate with such raw intensity that they slice right through soft human tissue, stopped only by the dense calcium of your bones. And finally, at the absolute extreme high end of the spectrum, we find gamma rays. These are the most energetic, terrifying electromagnetic waves in the known universe. They are forged in the blinding hearts of collapsing stars, in the chaotic annihilation of matter colliding with antimatter, and in the violently twisting magnetic fields surrounding black holes. A single gamma-ray burst from a dying star can release more energy in a few fleeting seconds than our sun will produce in its entire 10 billion-year lifespan. Yet, the most breathtaking realization about this vast, terrifying spectrum is not its sheer scale, but its underlying unity. It is a testament to the staggering economy of the universe. From the longest, gentlest radio wave drifting through a quiet room, to the visible light warming a blade of grass, to the most violent gamma ray tearing through the intergalactic void, they are all the exact same phenomenon. They are all just self-sustaining electric and magnetic fields dancing in the dark. They differ only in how rapidly they oscillate. A radio wave might cycle a few million times per second, while a gamma ray might vibrate 10 billion trillion times in that same second. But the fundamental engine driving them forward is absolutely identical. A changing electric field creates a changing magnetic field. A changing magnetic field creates a changing electric field. The cycle repeats, perfectly symmetrical, flawlessly regenerating itself without requiring a single atom of matter to support it. The equations do not care about the frequency. They do not have special cases or exceptions for different types of radiation. Every wave, no matter how gentle or how destructive, obeys the exact same laws and travels at the exact same absolute speed limit. But as we internalize this beautiful, unified picture of fields oscillating in the vacuum, a profound conceptual hurdle arises. It is a question that deeply challenges our classical, terrestrial understanding of physics. When we say that an electromagnetic wave carries energy across millions of light years of empty space, what does that actually physically mean? In our everyday experience, energy is always bound to matter. The energy of a raging ocean wave is stored in the tremendous kinetic motion and mass of millions of gallons of moving water. The energy of a deafening thunderclap is stored in the violent pressure and physical momentum of colliding air molecules. If electromagnetic waves are not made of matter, if they possess absolutely zero mass, and if they do not vibrate any physical substance, where exactly is the energy located? The answer forces us to abandon our reliance on physical mass. The energy is stored entirely within the fields themselves. Electric and magnetic fields are not just abstract mathematical concepts drawn on a chalkboard. They are real, physical entities that hold raw energy. A region of space where an electric field is strong literally contains more physical energy than a region where the field is weak. The same is absolutely true for magnetic fields. In a propagating electromagnetic wave, the energy is distributed throughout the space where the oscillating fields exist. As the electric field reaches its peak strength, it stores maximum electrical energy. A fraction of a microsecond later, as the electric field collapses through zero, the magnetic field surges to its peak, storing maximum magnetic energy. The energy constantly sloshes back and forth, trading flawlessly between the electric and magnetic states, perfectly conserved as the entire disturbance races forward through the void. This energy is not an abstraction. It is brutally real, and it can be extracted to do genuine physical work in our material world. Consider a standard solar panel sitting quietly on a roof under a clear blue sky. When the invisible electromagnetic waves from the sun strike the surface of the panel, the oscillating electric field within the wave physically pushes against the electrons trapped in the silicon atoms. It forces those electrons to move, driving them through a circuit to generate a flowing electric current. The energy powering the lights in a home, charging a battery, or running a machine came directly from the electromagnetic wave. That raw energy traveled 93 million miles from the burning surface of the sun, crossing the freezing, empty vacuum of space, carried entirely and exclusively by oscillating fields, completely independent of matter, until the exact moment it struck the silicon. Even more astonishingly, electromagnetic waves also carry momentum. In the macroscopic world we inhabit, momentum is an attribute strictly reserved for massive objects in motion: a speeding train, a thrown baseball, a falling rock. The idea of a massless wave possessing momentum seems to violate common sense. Yet, when an electromagnetic wave strikes a surface, it physically pushes on it. It exerts a very subtle but entirely real force known as radiation pressure. Because the fields themselves hold momentum, light can physically move matter. While the pressure of a single photon is vanishingly small, the combined force of sunlight is measurable, and it offers one of the most elegant methods for future cosmic exploration. Spacecraft can be equipped with massive, mirror-like solar sails, designed to catch the momentum of the sun's light. As the massless electromagnetic waves strike the reflective surface of the sail, they transfer their momentum, physically pushing the spacecraft forward through the vacuum. accelerating it to tremendous speeds without requiring a single drop of chemical fuel. A wave with absolutely no mass, no substance, and no material structure of any kind, traveling through pure emptiness, exerts a genuine physical force on the massive objects it encounters. The energy and the momentum are woven directly into the invisible fields. This reveals a universe that is far more strange and majestic than our ancestors could have ever possibly dreamed. We do not live in an empty, silent container of space. The vacuum around us is a rich, dynamic, and heavily structured arena. It hums with the relentless activity of overlapping fields. At this very moment, the space you occupy is saturated with an incomprehensible symphony of invisible light. The room around you is filled with the low-frequency radio whispers of human civilization, the sprawling microwave echoes left over from the fiery birth of the universe, the infrared heat signatures of the Earth itself, and the high-energy particles raining down from distant, dying stars. We walk through this dense, chaotic ocean of energy every second of our lives, blissfully unaware, completely blind to the towering waves crashing silently all around us. The void is not empty. It is a stage capable of holding immense power simply by allowing fields to exist, to oscillate, and to trade energy in the dark. The universe is a masterpiece of invisible architecture, proving that the most powerful forces in nature do not need mass, they do not need matter, and they do not need a medium. They simply need the bare, beautiful fabric of reality itself to carry their fire across the eternity of space. By the twilight of the 19th century, the architects of science believed they had finally conquered the dark. The universe, it seemed, was a grand, continuous masterpiece. James Clerk Maxwell had unified electricity and magnetism, proving that light was a seamless, self-sustaining wave propagating through the invisible fields of empty space. This classical picture was elegant, mathematically flawless, and deeply intuitive to the human mind. Energy was understood to be a continuous, unbroken flow, much like a river pouring smoothly through the cosmos. You could have any arbitrary amount of water in a river, and logic dictated that you could have any arbitrary amount of energy in a wave. There were no sudden gaps. There were no indivisible chunks. Reality was smooth. But nature harbors a profound, unyielding intolerance for human assumptions. The flawless, sweeping tapestry of classical physics did not unravel in the vastness of the cosmos, nor did it break down in the complex mathematics of the deep vacuum. It broke down inside the glowing, blistering heat of a simple metal furnace. The trouble started at the very dawn of the 20th century, in the year 1900. Physicists were grappling with a seemingly mundane, everyday problem: how hot objects radiate energy. When you place a heavy piece of iron into a roaring fire, it begins to glow. It shifts from a dull red to a bright orange, to a blinding white, and eventually to a searing blue as it gets hotter. Classical physics attempted to calculate exactly how much electromagnetic energy this glowing hot object should emit at various frequencies. The pristine mathematics of the continuous wave theory were applied to the furnace, but the equations produced an absolute physical absurdity. Classical physics confidently predicted that a glowing hot object should emit infinite energy at high frequencies. According to the established laws of nature, a simple warm piece of metal should be violently radiating an infinite storm of extreme ultraviolet energy, incinerating everything around it. This was obviously catastrophically wrong. Hot objects simply do not emit infinite energy. The energy output of a heated metal is finite, peaking at a specific color and gracefully dropping off at higher frequencies. The continuous wave picture, the bedrock of 19th century physics, was fundamentally broken. The German physicist Max Planck stared into this mathematical abyss and realized that the only way to fix the equations was to commit an act of theoretical heresy. Planck found that he could force the mathematics to match the experimental data, but only if he made an incredibly strange, deeply unnatural assumption. He had to abandon the comforting idea of a smooth, continuous river of light. He assumed that electromagnetic energy is not emitted or absorbed continuously in any arbitrary amount, but rather in discrete, indivisible packets. Imagine an ocean where the water can only flow in perfectly defined, unbreakable droplets. Planck proposed that each of these packets carries a specific, exact amount of energy determined entirely by the frequency of the radiation. Higher frequency light, like blue or violet, meant more energy per packet. Lower frequency light, like red, meant less energy per packet. He called these discrete, countable units quanta, deriving the term from the Latin word for how much. Planck himself was deeply, fundamentally uncomfortable with this radical idea. He was a classical physicist at heart, and he considered the quantum to be nothing more than a mathematical trick, a clever workaround engineered merely to force the equations to produce the right answer. He did not actually believe that the fundamental energy of the universe came chopped into discrete, jagged chunks. He desperately expected that someone, eventually, would find a way to derive the correct radiation formula without needing this absurd quantization. But the universe does not bend to our philosophical comforts. No one ever found that classical workaround, because the quantum was not a trick. It was the foundational, unyielding truth of reality. The true, terrifying reality of Planck's discrete packets was finally dragged into the light in 1905. Albert Einstein, possessing a mind unburdened by the dogmas of the past, turned his brilliant attention to a strange, lingering mystery known as the photoelectric effect. Scientists had observed a highly peculiar phenomenon where light shining on a metal surface physically ejects electrons from that metal. On the surface, this makes logical sense. Light carries energy, the energy strikes the metal, the electrons absorb the kinetic impact, and they are knocked loose. But the minute details of this interaction were violently contradicting the continuous wave theory of light. The bewildering part of the photoelectric effect was that it depended entirely on the frequency of the light and not its intensity. If you shone a very dim, incredibly faint blue light onto the metal surface, electrons would instantly pop out. But if you shone a blindingly bright, intensely powerful red light onto the exact same metal, absolutely nothing happened. No matter how bright you made the red light, no matter how long you left it shining, the electrons refused to budge. This made absolutely no sense if light was a continuous wave. In classical physics, a brighter wave fundamentally carries more total energy. Therefore, a massive, towering tidal wave of intensely bright red light should eventually deliver enough energy to knock the electrons loose. But it never did. Only light above a certain specific frequency could successfully eject the electrons, and below that critical frequency, no amount of brightness made any difference whatsoever. Einstein looked at this impossible puzzle and realized the staggering truth. Light is not a continuous, rolling wave crashing against the shore of the metal. Einstein proposed that light itself comes in discrete, localized packets, which we now call photons. He argued that each individual photon carries a specific, unyielding amount of energy dictated solely by its frequency. A photon of blue light vibrates at a higher frequency, and therefore it carries a large, concentrated spike of energy. A photon of red light vibrates at a lower frequency, carrying a much smaller, weaker amount of energy. When a beam of light strikes the metal, it is not washing over it like a fluid, it is raining down on the metal like a shower of hail. When a photon hits an electron in the metal, it transfers its energy to that electron in a single, instantaneous event. It is a strict one-to-one interaction. If the photon's individual energy is high enough, like the energetic blue photon, the electron absorbs it and violently escapes the metal. If the photon's energy is too low, like the weak red photon, the electron simply cannot escape its atomic bonds. And because it is a strict one-to-one interaction, no matter how many trillions of low-energy red photons you barrage the metal with, no single photon possesses the necessary strength to liberate an electron. Each interaction is one discrete photon transferring its energy to one discrete electron. The process is entirely discrete, not continuous. This revelation was both revolutionary and deeply, profoundly confusing. The scientific community was thrown into a state of severe intellectual whiplash. Light is a wave. Thomas Young had definitively proven that with his elegant double-slit interference experiment over a century earlier. Waves spread out, they bend around obstacles, they diffract, and they overlap to create intricate interference patterns. Light undeniably does all of these fluid things. But Einstein had just proven that light also comes in discrete, indivisible packets that interact with matter one at a time, exactly like solid particles. How can something possibly be both a continuous wave and a discrete particle at the exact same time? To the human mind, this seems like an irreconcilable contradiction. Waves are continuous disturbances spread out over vast expanses of space. Particles are localized, distinct points of matter. Waves can gracefully interfere with each other, amplifying and cancelling one another out. Particles violently bounce off each other like billiard balls. These are completely different categories of existence. For decades, humanity struggled to grasp this agonizing duality, desperately trying to force the universe to pick a side. But the universe refused. The answer, which took decades of grueling theoretical work to finally understand, requires us to completely dismantle our language. We must stop trying to force the cosmos into the crude, macroscopic boxes of human intuition. Photons are neither waves nor particles in the classical sense. The word particle is a dangerous linguistic trap. It forces the human mind to immediately picture a tiny, hard sphere, a microscopic grain of sand, or a miniature pellet shot out of the lens of a flashlight. But a photon is not a physical object. A photon is a quantum of the electromagnetic field. It is the absolute smallest possible excitation of the field at a given frequency. To visualize this alien concept, imagine a long, heavy guitar string pulled taut in a quiet room. When the string is perfectly at rest, it sits in its lowest possible energy state. It is not vibrating, but it holds the latent potential for music. Now, reach out and pluck it as gently as physically possible. You have added energy to the string, and it begins to vibrate at its fundamental frequency. Because of the physical laws governing the string, you cannot add less than this absolute minimum vibration. You can pluck it harder, which adds more quanta of vibration, piling energy into the system. But there is a distinct, unbreakable ground floor to the excitation, a smallest possible vibration that you simply cannot subdivide any further. The invisible electromagnetic field behaves in a remarkably similar way, except it is not confined to a wooden instrument. It seamlessly fills all of space. At any given frequency, the omnipresent electromagnetic field can sit in its absolute lowest energy state, which physicists call the ground state or the vacuum state. In this silent, freezing state, no photons are present. But if you add energy to this field, it becomes excited. When it is excited by exactly one quantum of energy, one photon is present. When it is excited by 2 quanta, two photons are present. Each individual photon is nothing more than one indivisible unit of excitation of the field at that specific frequency. The field is the fundamental, underlying reality. The photon is simply what happens when you excite that field by the minimum mathematical amount. This is precisely why photons are not little balls flying through space. A physical ball is an object that exists independently of its environment. You can put a ball in a box, you can hold it in your hand, and it possesses a definite size, a definite position, and a definite, predictable trajectory. A photon possesses none of these mechanical traits. A photon is a process. It is an excitation, a highly specific kind of mathematical activity occurring within the electromagnetic field. Asking where exactly the photon is located before you forcefully measure it is as meaningless as asking where exactly the vibration is located on a ringing guitar string. The vibration is not localized at one single point. It is a sprawling property spread across the entire length of the string. Similarly, a photon is a fluid property of the electromagnetic field, and the field seamlessly fills the empty space through which the photon travels. This profound realization flawlessly resolves the terrifying paradox of duality. This is exactly why light can behave as both a sprawling wave and a localized particle. Ultimately, it is neither. It is a quantum field excitation. When physicists perform macroscopic experiments that are exquisitely sensitive to the wave-like, fluid properties of the field, like Thomas Young's famous double-slit experiment, they see the beautiful, sweeping interference patterns. The excitation ripples and overlaps. When physicists perform microscopic experiments that are uniquely sensitive to the discrete, quantized nature of the field, like the photoelectric effect, they see sudden, particle-like behavior. The energy transfers in distinct, countable sparks. The photon is not magically switching its identity back and forth between being a wave and being a particle depending on who is looking at it in the laboratory. It is always the exact same thing, a quantum excitation of the underlying electromagnetic field. Different experiments simply reveal different mathematical aspects of that one singular underlying reality. When we finally let go of our desperate need for tiny, solid objects, the universe becomes infinitely more majestic. We are not bombarded by microscopic bullets of light. We are immersed in a vast, silent ocean of invisible fields. The stars are not shooting particles into the dark. They are plucking the cosmic strings of the vacuum. The light that travels for billions of years across the freezing void, the light that warms the oceans of our world and allows our eyes to see, is nothing more than a ripple of pure mathematics. It is a discrete, shivering excitation of the emptiness itself, reminding us that the fundamental nature of reality is not built from solid matter, but from the beautiful, indivisible sparks of a waking void. We are deeply accustomed to thinking of space as a massive, echoing container, an empty room into which all the objects of the universe can be placed. In this classical, intuitive picture, you can put furniture, air, or people into a room, but the room itself is nothing more than the empty volume, serving as a passive, inert background stage. The things existing inside the room are completely separate from the room itself. Following this terrestrial logic, if you were to meticulously remove every burning star, every drifting cloud of cosmic gas, and every stray atom, you would be left with the bare, featureless void of space. But the deepest, most astonishing revelations of modern physics tell us that this deeply ingrained picture is completely and utterly wrong. In the middle of the 20th century, brilliant physicists including Paul Dirac, Richard Feynman, Julian Schwinger, and Shinichiro Tominaga developed an extraordinary theoretical framework known as quantum field theory. They'd built this profound architecture to finally combine the strange, microscopic rules of quantum mechanics with Albert Einstein's special theory of relativity. What emerged from their mathematics was a radical reimagining of reality. Quantum field theory dictates that the invisible quantum fields are not merely objects or furniture placed inside the room of space. Instead, they are the very walls, the floor, and the ceiling. They are an inextricable part of the room's fundamental structure. According to this framework, every single type of fundamental particle in the cosmos corresponds to a unique quantum field that entirely fills all of space. Electrons are simply localized excitations of the universal electron field. Quarks are excitations of the quark fields, and photons are the excitations of the omnipresent electromagnetic field. There is a specific, dedicated field for every single particle type, and every one of these fields stretches continuously across the entire universe. You cannot remove them and be left with bare space, because without the fields, there is no space left in any physically meaningful sense. The electromagnetic field does not just occupy space the way a solid table occupies a dining room. It is part of what makes space the kind of space it actually is. It is permanently present at every conceivable point, extending even into the most remote, desolate voids between distant galaxy clusters. It is woven inextricably into the very location itself. This realization forces us to completely redefine the word empty. When a physicist says a region of deep space is empty, they merely mean that no particles are present, but the underlying fields have not vanished. They are still there, sitting quietly in their lowest possible energy state, which we call the ground state or the vacuum state. The vacuum is exactly what you get when every single quantum field is resting in this absolute lowest state, completely devoid of photons, electrons, quarks, or particles of any kind. But the fields themselves continue to permeate every single cubic centimeter of the vacuum. They do not disappear just because they are not currently excited. They are always extending through every coordinate in the universe, lying in wait, perpetually ready to be excited into producing a particle if enough energy is suddenly introduced. Empty space is not a blank, featureless nothingness. It is simply the quietest possible state of a fantastically complex, multi-layered field structure that holds the entire cosmos together. But even in this state of ultimate quiet, the void is never truly silent. The underlying laws of the quantum realm enforce a restless chaos at the very bottom of reality. Werner Heisenberg's uncertainty principle dictates that certain pairs of physical properties cannot both be precisely determined at the exact same time. This strict rule applies to the invisible quantum fields just as rigorously as it applies to physical particles. Specifically, the absolute field strength and the exact rate of change of that field cannot both be perfectly zero simultaneously. Because of this inescapable mathematical law, the electromagnetic field is constantly flickering and fluctuating, even in the absolute vacuum state when zero photons are present. The field strength randomly and unpredictably jiggles slightly above and slightly below zero. These spontaneous, shivering movements are known as vacuum fluctuations, and they are not mere theoretical speculation or philosophical poetry. They have been meticulously measured in laboratories, and they produce undeniable, observable physical consequences. In 1948, the Dutch physicist Hendrik Casimir predicted one of the most stunning demonstrations of this humming void. He showed that if you place two perfectly flat, uncharged, conducting metal plates incredibly close together within a perfect vacuum, those plates will experience a tiny but measurable attractive force physically pushing them toward one another. This strange push does not come from gravity, which would be vanishingly weak. nor does it come from any electrical charge residing on the metal plates. It comes directly from the vacuum fluctuations of the electromagnetic field. The quantum vacuum surrounding the plates is actively boiling with fluctuating fields at all possible frequencies. Outside the tiny gap between the plates, fluctuations of every conceivable wavelength can freely exist, pressing inward. However, inside the microscopic gap between the plates, only the specific wavelengths that fit neatly can survive, while all the other mismatched wavelengths are physically suppressed. This creates a severe cosmic imbalance. There are vastly more quantum fluctuations violently pushing on the plates from the outside than there are pushing from the inside, generating a net force that physically squeezes the plates together. This Casimir effect is direct, unassailable physical evidence that the vacuum is not empty in the classical sense. The void holds structure, it holds energy, and it physically interacts with the matter placed inside it. Another extraordinary proof of this boiling nothingness is the Lamb shift, discovered by Willis Lamb in 1947. Lamb detected a tiny, anomalous difference in the energy levels of hydrogen atoms that classical physics and early quantum theory were entirely unable to explain. The ultimate explanation revealed that the vacuum fluctuations of the electromagnetic field were physically interacting with the electron orbiting inside the hydrogen atom. The constantly flickering fields of the vacuum gently nudge the electron, shifting its energy levels by a microscopic but brilliantly measurable amount. Calculations mapping this effect using quantum electrodynamics match experimental reality with an almost terrifying precision, agreeing to more than 10 decimal places. It remains one of the most precise agreements between human theory and physical experiment in the entire history of science. These astonishing effects compel us to understand that empty space has a dynamic architecture. It has latent energy, and its fluctuating fields hum with relentless quantum activity. But we must navigate this realization with extreme caution, avoiding the intellectual trap that snared the physicists of the 19th century. The fact that the vacuum has structure and energy does not mean that the vacuum is a material medium. It absolutely does not mean that we have accidentally reinvented the luminiferous ether and simply disguised it under a modern name. The quantum field structure of the vacuum is fundamentally, profoundly different from any material substance. Air flows, bounces, and carries mechanical disturbances through the physical collision of molecules. Water splashes and holds itself together through intermolecular forces. The quantum vacuum possesses absolutely none of these mechanical traits. There are no molecules hiding in the dark. There is no physical substance that mechanically jiggles, compresses, or flows. The quantum fields are not made of anything smaller or more basic. They are the absolute bottom layer of physical reality. This brings us, finally, to the ultimate resolution of the great paradox. We can now answer the haunting question that sparked this entire cosmic journey. How can nothingness carry an electromagnetic wave? It can do so because empty space is not the blank, featureless void our primitive terrestrial intuition imagined it to be. Empty space is the ground state of the quantum fields that span the entire universe, and the electromagnetic field is a permanent, indelible part of that reality. It exists everywhere, saturating every coordinate in space, entirely regardless of whether any physical matter is present. When this omnipresent field is disturbed, when a changing electric field creates a magnetic field, which in turn creates a new electric field, which creates yet another magnetic field, the disturbance seamlessly propagates through the field at the speed of light. The vacuum allows this breathtaking propagation to happen not because it contains some hidden stuff for the wave to physically vibrate, but because the electromagnetic field permeates all of space and fundamentally supports self-sustaining oscillations as an inherent property of its very existence. The precise constants that strictly determine the speed of light. the electric permittivity and the magnetic permeability, are not the properties of some invisible cosmic jelly. They are the intrinsic properties of the quantum field structure of empty space itself. The wave does not need a material medium because the field is its own medium, a category of reality entirely distinct from matter, completely capable of existing in the total absence of physical substance. A photon, the brilliant quantum of light, is not a tiny physical ball traveling through this field like a silver fish swimming through a black ocean. The photon is the field itself, beautifully excited by a single quantum of energy. Just as a wave on a guitar string is not an entity separate from the string, but rather a temporary action performed by the string, the photon is an action performed by the electromagnetic field. When we say that a photon travels from a distant, burning star to your waiting eye, what we actually mean is that a quantum excitation of the electromagnetic field elegantly propagated across the cosmos. The field was sitting there the entire time, stretching unbroken across every single point between the dying star and your retina. The excitation merely rippled through it. This majestic perspective completely resolves the ancient puzzle. We no longer need to desperately ask what invisible physical substance fills the freezing void between the galaxies. The void is filled with quantum fields resting in their silent ground state. We no longer need to invent a ghost like the ether to carry the light of the universe. The electromagnetic field actively does the carrying, and it requires no physical substance to support it because the field is fundamental, not derived from anything more basic or material. We no longer need to agonizingly wonder how a wave can exist in pure nothingness. The wave does not exist in nothingness. It exists in the electromagnetic field, and the electromagnetic field exists everywhere. When you step outside on a cold, clear night and look up at the sprawling canopy of the heavens, you are looking at the ultimate proof of this hidden reality. The light that strikes your eyes has traveled for years, centuries, or even millions of millennia. During that entire epic journey, no physical material supported it, and no invisible ether cradled it. The photons were simply discrete excitations of the electromagnetic field, sustained by the endless, perfect dance of electric and magnetic fields regenerating each other across the cosmic emptiness. The vacuum did not carry the light the way a river mechanically carries a fallen leaf. The vacuum simply allowed the light to exist, because the electromagnetic field is part of what the vacuum inherently is. Every single point of starlight you see is a message, a testament confirming that empty space possesses an exquisite, invisible structure. The vacuum carries light the way mathematics carries truth. Not by being built out of the right material, but by possessing the perfect, fundamental structure. What we once called nothingness turns out to be one of the most extraordinary, complex, and beautiful somethings in all of physics. It is a shimmering, humming web of quantum fields, capable of supporting disturbances that race across eternity at the speed of light, carrying the energy and the visual history of the universe through the dark, needing absolutely nothing more than the bare, beautiful fabric of reality itself. Good night, and see you in the next video.